So here we are. Are cremation diamonds real? Are they authentic? That's the key. And independent research. Now, I want to, and let's see if I can make all this happen correctly. I love the little pointers with this. I have a little laser pointer now. Isn't that cool? I want to acknowledge the deep research and analytical support of ChatGPT, Google Gemini, Microsoft Pilot, actually Google Search AI. The advancement of artificial intelligence is crucial in getting research done these days. Now, I want to tell you something. It's important that you know that if you're doing searches with AI, you ask garbage questions, you get garbage answers. So there's something that I learned at that JCK seminar in Las Vegas. You've got to be very specific when you're dealing with AI to ask the questions to narrow this down. Because the problem is this: when you get into these things, this webinar includes only the scientific evidence from published and peer-reviewed professional scientific organizations. Why do I tell you that? Well, when you first start searching for cremation diamonds with Google search, for instance, you get regurgitated a lot of what's supposedly science from the cremation diamond websites. And I ask AI about that, and you can actually interact with AI. Those of you that are not done it with each other, it's almost like I got somebody in the room with me that I can sit here and type on a keyboard and ask questions and have a conversation with. And I was like, why is it when I ask for the same concept about getting carbon out of ashes, if I ask for scientifically, which is carbon-14, because the process to get carbon out of these cremation ashes for carbon-14 testing by the scientific community is the same purpose that cremation diamonds are. They're extracting carbon from ashes. What they do with that after they get it, it doesn't matter, but it's the same process. But when I talk to AI about it in the context of cremation diamonds, all I get is the stuff out of the cremation diamond websites, and they treat it as science. But when I say, no, I want strictly scientific information published and peer-reviewed by professional scientific organizations, published in scientific journals, all of a sudden the science showed up. All of a sudden, all the cremation diamond stuff went away, the science showed up, and the whole story changed. It was astounding. Anyway, I wanted to tell you all that this is actually what Google search told me. They said for cremation diamonds, they use the commercial websites. And for scientific testing, they pull from the academic papers. So I said, just use academic papers and let's learn about cremation and carbon. And that's what we did. Now, once again, it's the same thing. I don't care if you're using the carbon for carbon-14 dating or if you're using it for cremation diamonds or whatever else. The process for extracting carbon from cremated bones is the same. Now, the first question is just how much carbon is in a component of a human bone? In other words, is carbon a major component that you could say, okay, we can draw a bunch of carbon? The answer is no. It's a trace element. And here's the chemical equation for human bone. And carbon's not in there. This is from the Chemical Society. And this is going to be important as we go along. And I'm going to move through this. I'm going to do a paper on this later. If you missed some of this and say, wow, we went kind of fast through that, I'm going to do a full paper, a full report on this. But tonight I wanted to share with you the basics of what we're seeing. From the Journal of Radio and Analytical and Nuclear Chemistry, I'm going to be throwing a lot because, folks, I've got this backed up with scientific proof and scientific journals and scientific reports. And what you're going to see tonight is just a fraction. You don't see any carbon in here. Carbon is C. I'm not a scientist. I don't profess to be a scientist. I'm an insurance investigator. But you have to learn how to certain amount of this. You don't see carbon in here. This is the elemental concentrations in freeze-dried human bones. And there's another one here that shows the same thing. This is from the International Atomic Energy Commission. Minor and trace elements in human bones. You don't see carbon. Carbon is a very minute trace element in human bones, because in spite of the fact that some of the cremation diamond companies say that human bones are calcium carbonate, they're actually a calcium phosphate. A lot of difference to that. They're not calcium carbonate. That's what seashells are. And finally, from the Journal of Applied Spectroscopy. Once again, elemental composition of human bone. So you don't have carbon as a major component, of human bone. And we've got the science to back that up. Now, here's the problem, and here's where we get into. Cremation ovens burn between 760 C and 1000 C, and we're dealing with centigrade tonight. I'm sorry for those of you, because I know most everybody's from the US deals in Fahrenheit, but scientific studies and scientific reports are almost always in centigrade, and I'll try to translate that over when I can. But basically 1400 to 1800 Fahrenheit. Now, all carbon in the body, all the organic carbon, this is everything, burns up by 600 degrees centigrade. Look at this again. Cremation ovens burn 760 C to 1000 C. All the carbon is gone by 600 C. This is crucial. And we've got the scientific studies to show it. The temperature is a combustion and controlling factor in the process. All organic carbon is burned away by around 600 C. And it shifts from a gray to a bluish gray. It turns white, actually, past 650. And the calcined state is the burnt state. That's when it's all burned up. And in the lower part of this page, you're seeing determination of presence of remains using the chemical composition of burned cadaver ash. That's from University of Montana. At 600 degrees Celsius, the carbon's gone. All the organic carbon's gone. So that point that I have always stated, that the carbon's all burned up, the organic carbon is supported by the science. And this was fun to find, because I already had a couple of these studies, but I got a lot more dealing with the deep search on artificial intelligence. But it confirms that what we're dealing with here, as far as the cremation ashes, all the organic stuff is gone. That's gone. Now, this is the timeline of what happens inside a cremation oven. And you'll notice from this, with my little laser pointer here, the pyrolysis, this is where this is all burned. This is where all the material burns and gets blackened and charred. And you finally, when you get up to close to 600, it's all oxidized. It's all burned up. It's all gone. And the calcination of the bone, the bone is all burned up between 600 to about 8. And this is important. This is crucial. At between 800 and 1000 centigrade, there's crystal growth. And this is part that I didn't know. This is part of what this deep research with artificial intelligence has been so amazing. There's crystal growth happens there. And that inside those crystals, those little tiny crystals, that's where the trace carbon is. It's the rest of it's gone everywhere else. And remember again, at 600 C, all the organic's gone, and all these little crystals that starts forming happens like up between 800 and 1000 C. Now, here's another study. I got a ton of studies. I had to start cutting them back because I had so many I knew that it'd be kind of boring. But in this, it shows that when everything is done, all organic materials, including collagen is the carbon, is destroyed. The only remaining carbon is inorganic in the form of carbonate embedded in the mineral matrix. And that mineral matrix are these little tiny apatite crystals. Hydroxyapatite is what they're called. And it's inorganic. It's in the form of carbonates. And this once again shows that it goes through a series of stages and it finally crystallizes into bioapatite. Now, when these crystallizations starts happening, carbon's already gone. The carbon from the body is already gone. But it starts forming these bioapatites, and there's trace elements of carbon in those. It's going to be interesting to see exactly where they come from. And this again is from Cambridge University Press. This is all backed by the science, folks. This is something that I was really stickler about. I was not going to present any of this unless I could really show a lot of scientific studies from proper journals that demonstrated it. And once again, remember the time frame for all this happening. All the organic carbon is gone in here, and these little crystals start showing up in here. Now, why does it turn to apatite? And these little crystals are apatite. And this is what's cool, because, well, I say it's cool. I'm sorry, that sounds a little macabre. I've been studying this so much that I look at this like like an investigator. Cremation, I don't know if any of you all have handled cremation ash. I just in the course, I don't know, out on the island when I lived out in Corpus Christi, out on the island, we would have something that we'd get that would be burned up. Anyway, cremation ashes are grainy. They're not like dust, like ashes. You know, you get a fireplace, you get ashes, and it's just a real fine powder dust. Cremation ashes are grainy because of the crystallizations. And what happens, it turns to apatite. Why apatite? Well, look at the chemical equation. Right here, you've got the chemical equation for human bone. It's a calcium phosphate. You don't see any carbon in here. It's calcium phosphate. What's the chemical equation for apatite? Chemical phosphate. With the addition here of the fluorine and chlorine, and this is why when all this starts getting so hot, when it gets over 800 degrees centigrade and it gets so hot it starts forming little crystals, it forms into apatite simply because the chemical equations for the two are virtually identical. And that's why it happens. That was the explanation that was presented to me. That's not my evaluation. That's the way that it was presented to me. And this is the study that actually brought it all home, that the FTIR and X-ray diffraction confirmed the complete loss of organics, loss of carbonates, significant crystallographic changes in cremated bone apatite. And here, once again, this is studies, and I'm sorry, sometimes I realize I may have more studies than what are actually necessary to make the point, but they make hexagonal forms, closely packed hexagonal forms. They recrystallize after the 650, that's after all the organics gone. They closely packed hexagonal forms. Now, once again, we go back, is there carbon present? Yes, in the apatite crystals. Where is that carbon? It's chemically locked in the crystal structure of the apatite. It's chemically locked in the gemstone. And this is what it's locked in. And I have to tell you, the reason we know it's hexagonal, and this is what was so cool about that study that talked about the hexagonal, tightly packed hexagonal crystals, was because apatite forms as hexagonal. We know we have hexagonal apatite crystals that we study. We just had the whole thing on apatite. We had the blue, the neon blue apatite. That's what this stuff is. And this is an apatite crystal. This happens to be a yellow. But that's what all this is forming into. And the carbon is locked inside the crystal lattice of this crystal. Not this one, obviously, but the ones in the cremation ashes, but it's the apatite crystals. So the question is, if all the carbon burned away at 600 degrees centigrade, and these crystals started growing at 650, 700 centigrade, where did this carbon come from? That's the question. ChatGPT gave me a couple of little charts here that I thought would be cool, and I was like, okay, I'll use it. Honestly, you start interacting with artificial intelligence as if you've got somebody that you're, talking to in the room. And yes, perhaps I need to get more friends, but I got to tell you, it was pretty cool doing all this deep research with the artificial intelligence. This gives you an idea just about the carbon in the lattice, but even more so in this. And Google Gemini came up with this. And I want you to look at something here. This is a drawing. This is actually from a scientific website. But look at all of the chemicals based in here. This is all part of the hydroxyapatite crystal lattice. This is all, and the only place you find carbon's right here. That's the only place you see C. If you look at the whole chemical structure of this thing, that's the only carbon you got. And I actually got Google Gemini to do a 3D rendition of this. And I thought this was very cool and very graphic. This demonstrates to you the carbon, the red. The little red is the carbon atoms in this hydroxyapatite crystal after cremation. This is what it looks like. And you'll notice you've got the calcium atoms, you've got the phosphate groups, You've got increased crystallinity. Can't say all these words. Post-cremation, this all happens late in the process, and you've got very small trace elements of carbon in here. And this is based on the science, folks. So with all of this, we go back, is there carbon present? Yeah, there's some carbon present in these apatite crystals, these hydroxyapatite. And it formed after all the organic carbon burned away. How much carbon's in there? According to the studies, anywhere from 0.10% to 1%. And this is based on the scientific study. This is a widely used study about the carbon in the cremation ashes. And this verifies that kind of percentage. It's not 1 to 4%, like some of the cremation diamond companies claim. It's 0.1% to 1%. And that's carbon in the carbonate of the crystal. That's not sitting out where we can use it for a diamond. It's locked into a crystal lattice, and you've got to find a way to extract that, and you've got to find a way to purify it. So what you wind up with is a lot less. This is just something that actually ChatGPT made for me. This shows 30/100ths of one. It's a 30th of 1%, I guess you would say, which is kind of an average of how much carbon is in one of these hydroxyapatite crystals, just to give you an idea how small, how minute the amount of carbon is in there. And once again, the time frame to know that this happened here after all the organic carbon burned up here. So where did it come from? How does the carbon get in these apatite crystals at temperatures over 700 degrees centigrade when all organic carbon is done by 600 centigrade? That was my question. That was the question that I put out there, because I was like, wait a minute. All of this stuff is burned up. All the organic stuff is burned up and gone. And now that we've got the chemical elements left over from the calcium phosphate bones creating some apatite crystals, where's that carbon coming from? Now you got to brace yourself for this. And when I first heard this, I was like, there's no way I'm going to be able to tell people this, because it sounds so crazy. But you know what? It's backed by science, and it's backed by some big science. So get ready for this. The most probable source of carbon in cremation diamonds. You ready? Dramatic impact. Natural gas. Hydrocarbons. Now, when I first saw this, I was like, I mean, when we were going back and forth with artificial intelligence, I was like, oh yeah, the studies are absolutely, without question, hydrocarbons. That is one of a major source of where this carbon comes from, and I want to show you why. These are the actual. Let me get. I've got to get this on my screen here. And I want to just go through this carefully. Experimental studies have shown that during the burning process, up to 95% of the bioapatite carbon can be replaced by carbon originating from the fuel. Cremation ovens use natural gas, whether it's the propane, the methane, whatever else. They're using natural gas. It's a hydrocarbon, and it's in the environment when all these little crystals and everything are forming up. And according to this study, not up to 95% of the carbon in those apatite crystals can be replaced by the carbon coming off the fuel, because it's all in the air around in the chamber. The second one is even more so. The carbon dioxide in the atmosphere combustion is almost entirely derived from fuel. So the whole atmosphere is derived from the fuel. It's full of carbon dioxide, to the extent that between 67 with a ±3 to 91 ±8% of the carbon in the calcined bone derives from that source. What that is saying is that 67 to 91% with the ±8, it could be 99, of the carbon in the bone comes from the source, the fuel, the natural gas. And it makes sense because natural gas is hydrocarbon. And when I saw this, and I was like, damn, honestly, I was like, I had never thought about this, and I had never heard about it until, both Google Gemini and ChatGPT said, oh yeah, the fuel. It's called old wood. The concept is called old wood. Why do they call it old wood? Here's why they call it old wood. Because when the studies from all these universities were trying to do carbon-14 dating for all these archaeologicals, they found that it was being skewed, that the dates were off. And they called it old wood because, as it turned out, some of these cremations were done by old wood. It was wood of a tree that's 200 years old, 300 years old or something, and they cut the wood down, the big oak trees in England, things like that. And that carbon from that fuel goes into these apatite crystals so that when they withdraw the carbon, it's skewed because the carbon is that much older. So when you look at this, it's not a matter that we're trying to do carbon-14 dating. It's a matter that we are looking to see what that carbon is in there. How'd that carbon get in there? What's the source of that carbon in these cremation ashes, in these little crystals, these hydroxy apatite crystals? Talk so fast, I get messed up. It's from the fuel. And once we got that into there and saw this, and I was like, oh my God, the whole fuel concept is pure. Well, how much carbon is it? Let's look to see. So you got this one. Now, here's what happens. This is natural gas, and this is what's used in a cremation oven. Methane is used the most because that is what's considered natural gas, but you also have propane. Anybody that's had a propane tank or had a barbecue, butane, of course, is a lot used in lighters. But look at the numbers here, and this is from one of the energy companies. Carbon in methane makes up 74.9%. And the carbon in propane makes up 81.75%. They're overwhelmingly carbon, and they're burning, and they're in the atmosphere when these hydroxyapatite crystals are forming at the later stages of cremation. And so you've got a situation here where you've got no organic carbon, but you've got hydrocarbons very readily available. And the scientific study says up to 99% of this can be that. Now, here is something from Enbridge Gas, which is a big gas company, and the United States Environmental Protection Agency, and a couple of others. I don't really like Wikipedia for a source, but it just sneaks in once in a while. But most important here was Enbridge Gas and USAA P&C. Look at the numbers of the amount of carbon released into the atmosphere in a cremation oven. The carbon released here, natural gas, 1.6, 2.2 kilos. You're talking about anywhere from maybe 3 to 4.5 pounds of carbon that's in the atmosphere during the cremation oven when it's all happening, and all that carbon is available. It's 6 to 8 kilos of carbon dioxide. The gas, the natural gas that's burning, is just filling that chamber up with carbon at the time that these crystals are forming. And this gives you an idea. This is just a cremation fuel carbon impact. This is another one that I had. Actually, I think Google Gemini did this, just to show you the carbon dioxide emissions per cremation. 7 kilos, 8.5, 9.7 for diesel. I don't know of any cremation ovens that use diesel. I just don't know. But the amount of carbon that they put into the atmosphere when these hydroxyapatite crystals are really forming up is huge. I just want to review this again. Take a look at this. This dilutes the claim that the carbon being extracted from ashes to make cremated diamonds is all from the loved one. How can they prove it? How can cremation diamonds prove that they're actually extracting carbon from the loved one and not from the source? And if all the organic carbon was gone at 600 degrees centigrade and all of the stuff formed up at 800 degrees, if it's not the fuel, where's it coming from? And I've got a little answer for that for you in just a minute. But the fact is, there's serious questions. If you look at the science of cremation ashes, what's in them, how what's in them got there, you start having to question. The point being is the lab created diamonds sold to customers as cremation diamonds have a high probability of containing carbon from the cremation oven furnace that is burning natural gas, which of course are hydrocarbons. There's a high probability based on the actual scientific research and the actual scientific journals that there's a high probability that the carbon that's being extracted is actually from the hydrocarbons, from the natural gas. But the question is, are they really harvesting carbon at all? Are the cremation diamond companies really harvesting the carbon that they say they are? Let's just say that there's carbon. Let's just say that there's natural gas carbon that's got caught up in these, are they really extracting it? Let's first look at the published scientific method of extracting carbon from these crystals. I want to first look at that. If this looks long and convoluted, it's because it is. This was from a gathering of scientists in a big science symposium. This was actually published by the University of Arizona. Once again, science. We get science reports. And it talks about the fact that what you have to do, there's a lot of treating the ashes and the little crystals. You have to grind them up, then you use acids, and you have to do various tests, acetic acid, phosphoric acid. There's all kinds of acids you have to use that eats up the crystal structure and releases the carbon that is in there as carbon dioxide. And they have to trap that gas, extract the carbon, and try to purify that, and then have that carbon, which is whatever's in there that they get. And then they got the problem is where's that carbon from? But this is the accepted method of doing this. And this is what most of the published methods of extracting carbon is all about. Now, Eternova, for instance, claims to use total carbon analysis to recover the carbon. This is a high temperature method. It's a legitimate method that burns with pure carbon at very high temperatures, and it just simply burns the apatite into a gas. And then they trap the gas and they get the carbon from that. And the total carbon analysis is a system that's viable. The question is, though, goes back to where's that carbon from? Because that's the one thing they can't answer, particularly with what we have now. The fact that all the organic carbon's gone and the crystals have formed up after, and there's questions where that carbon's from, and being able to prove it's from the loved one, and how are you going to do that with considering what the math would be, just trying to work this out. But it's something that it makes you question the process. It's one thing to say, yes, this is what we do. There's something else to prove that that's what you do. And that's one of the biggest things, because to prove that what you're doing, you have to have it peer reviewed and you have to have it independently verified. Scientific processes like this have to be repeatable and predictable. You have to be repeatable and predictable, and it needs to be peer reviewed independently. I know that there's a couple of studies that are out there that for instance, Eternova, and I hope I'm pronouncing that right, I said they had, but the problem is they paid for it. And as we learn in Tibet Andesine, the scientific community, so there's a lot of them that are for sale. There's PhDs that are for sale. They'll generate whatever you want. It's got to be independent, and it's got to be something repeatable to be able to do that. Cremation diamond companies hide behind the word proprietary. Well, that's proprietary, we're not going to tell you. That's all fine, but you're claiming a scientific process to sell a product that's an extremely inflated and high price. And if you're going to claim that scientific process, you need to prove that it's true, that it's right, that it's accurate. And the only way to do that is independently. And I put that idea to the Google Search AI. And I use Google Search AI from time to time. And I asked, are there any scientific studies that support Eternova's method of carbon extraction, that what they actually do works? I know that the carbon extraction method that they talk about, the high temperature that just burns it into gas, I know that exists, but do they have any proof that's what's doing and proof that they're getting loved ones' ashes? And this is what was said. As of 2025, there's no independent peer-reviewed scientific studies that have validated Eterniva's method of extracting carbon from cremation ashes. And this is not me, folks. This is Google search telling me this. The company's claims contradict established scientific understanding of cremation process, which independent experts assert leaves little or no carbon in the final ashes. And that's where kind of we get stuck with all this, because once again, there's no proof of what's going on. And the science that we see raises serious questions about whether this is really going on or not. Now, this is where it comes down to this. This is from their website, that the carbon remaining is reduced from 18.5 to roughly 1.4. They make it sound as if the carbon in the body is because 18.5 is roughly the carbon amount in a human body, in all the organics. They make it sound like that the organics go from 18.5 to roughly 1.4. That's not true. The organics are gone. They're burned up at 600 C. And there's not a significant amount left behind. There's just not. We've already seen the actual scientific studies. This is why that the search engines pick this up, and they'll say, oh yeah, there's 1.4, and they'll say, yeah, the science says they're 1.4. Well, it's not science, it's the Cremation Diamond Company saying it, because in fact, it's not correct. The radiocarbon dating of calcined bone, as published in 2009, shows that the bones, which is all that's left, the bones had 4.9% carbonate, and after cremation, only 0.8 to 2.6 remain. That equates, as far as weight percentage, 0.08 to 0.26. That's 0.08 of 1% to 0.26. And that's just an extremely small amount. It's certainly not 1.4. And it's certainly not the organic 18.5 leaving 1.4, because the organics leave zero. So this becomes a problem, because what's being told to consumers is not being supported by the science at all. And we look again, what's in there, what is in there, we've got up to 99%, according to the studies, came from the fuel, came from the hydrocarbons from the fuel. Okay, now we're getting down to the end here. There's one more issue that undermines particularly Eterniva's claim of using carbon from a loved one to make a diamond. If we take all of this in its entirety so far, and I think everybody will agree that the science really shows there's serious problems with the idea of the cremation diamonds being authentic, there's another problem. There's one more problem that I had to laugh at when I saw. And in fact, it was just like, I can't believe they're doing this. I can't believe they're doing this. Anybody with a high school science class under their belt would understand it, and that's their lab procedure. Why is Eterniva using graphite crucibles when they're supposed to be isolating carbon from a loved one's ashes? The carbon crucible is going to leach in the mix. It says right here, and I just got this today, I took it off their website today. Once the ashes or hair arrive in our lab, a lab tech transfers them from the jar they came into to a graphite crucible. What is graphite? Look on the right side. It's carbon. Graphite's carbon. That's what graphite is. And graphite, anybody that's worked with a graphite crucible knows that graphite crucibles will leach out carbon into the mix. So what happens? The cremation diamonds the cremation ashes come in. The first thing they do is put it into the very crucible that's going to add outside foreign carbon into the mix and make it that much more difficult. And it's going to dilute their ability to claim that they can isolate a loved one's carbon when they put it into a graphite crucible to begin with. ChatGPT actually made this for me, and because it asked, do you want me to make you a little thing to show what this is? And it said graphite crucibles make cremation diamonds scientifically impossible. After cremation, only a tiny trace of carbon remains in the bones, too little to grow a diamond. Graphite crucibles leach carbon into the mix at the high temperatures used. Any diamond could be made from the crucible's carbon and not from the ashes. The process is scientifically unverifiable and misleading. And that's ChatGPT wrote that because based on its review and research into Eterniva's use of graphite crucibles. I just, honestly, when I saw that, I thought this is just crazy. Anyway, I did go back and ask Google search, based on all this, should consumers really be using the cremation diamond companies? And in this case, because they have such a huge presence, Eterniva has such a huge presence and has such a rich presence that they overwhelm all the information on the internet. And I got Google search and I asked them specifically, should they be used as a scientific information source when people are asking about cremation diamonds? This is not me saying it. This is Google search. This is what the Google AI search said. Based on expert analysis, Eterniva should not be used as a source for scientific information because its claims are disputed by independent research and lack transparent peer-reviewed validation. The company's scientific claims have been widely challenged by independent gemologists and scientific reports which contrast starkly with self-promoted marketing. And then there's a whole list of things of why. Honestly, I did a newsletter yesterday about doing searches with AI on cremation diamonds, and there's a whole list, and I published this, a whole PDF list this long. And it's just not. There's just so many things about this that are not right that you need to go to the actual science. You can't get your scientific answers from the cremation diamond companies, and I think this whole presentation underscores that. So the final answer, for me, cremation diamonds are real diamonds. What they're delivering are real diamonds. I don't think there's any questions of what the cremation diamond companies are actually delivering. But there's no proof that they contain any carbon from a loved one's organic carbon. In fact, just the opposite is true. Based on peer-reviewed scientific research, cremation diamonds have a high probability of containing carbon from natural gas or the graphite crucible. It could be coming from anywhere. There's no way to verify it. But there's one more consideration I want to tell you, and that's a price. And we're not going to spend time going deep into this because it's a whole nother report. The average, as you all know, lab-created diamonds have gotten cheap. Lab-created diamonds got cheap. I've got a whole bag of half-carat diamonds over here that I got, and I got those for $68 a piece. A 1-carat lab-created diamond on the market, open market, if you go in to buy it at retail, it could be $700 or so. The average cremation diamond, 1 carat, is running up to $15,000. Now think about that with all of the science we've provided here, all of the scientifically verified, peer-reviewed, journal-published science we've done. Is it justified to spend $15,000 on what's being claimed as a cremation diamond? I will leave that up to consumers. I'm not going to tell anybody. One thing I'm not doing here is saying, don't buy this, don't buy. I'm not saying any of that. I'm saying consumers need to know the information to make an informed decision. You need to look at the actual science. You need to look at the actual science reports. You need to look at all this documentation and make an informed decision about whether or not you want to buy cremation diamonds or not. And that's what this is all about.